Let's talk a little bit about do-it-yourself, DIY, versus AWS. We've talked a lot about it, but I wanted to give you a visual of, again, what it is like to do it yourself versus AWS. So with do it yourself, you have the concept of scale up. What does that mean? Well, you make a large purchase today of 100 servers, and that might serve you for, let's say, 6 months or a year. And then you make an acquisition or a merger, or something happens where you need more capacity. So what do you do? Well, the business tells you that we're acquiring another company, and that other company is maybe half of our size. Well, half of our size means I might need another 50 servers. So what do you do automatically? You over provision, which means if you need 50 servers, you're most likely going to go out and buy 100 servers. So you've just added another 100 servers for a total of 200 servers, and so on and so forth. With AWS, you don't need to do that. The Elastic service allows you to scale up and scale down as you need. So if you need 100 servers today, you can scale up to 100 server. If tomorrow you don't need these 100 servers and all you need is 50 servers, you scale down to 50 servers. Now just imagine the cost savings in terms of capital expenditure that you've just saved between the do-it-yourself method and AWS, and it's on the fly. It takes weeks, it's immediately. You can take advantage of these types of services. With do-it-yourself, with a traditional on-premises data center without cloud, you have to assume reliable infrastructure. You're building your infrastructure in a way where the application is assuming reliable infrastructure. You're doing clustering at the operating system level. You're replicating your SANs. You have failover capabilities on the network. You are building a reliable infrastructure. Guess what? With Amazon Web Services, with cloud in general, expect infrastructure failure. What are you, crazy, Eli? No, I'm not crazy. They are giving you a platform and they're telling you it is going to fail. Build your applications, build your infrastructure around the concept that it's going to fail. Now, if you step back and think about it for a second, which option would you prefer? Now, obviously, for the longest time, I was on the left, right? I would prefer to build and assume a reliable infrastructure. But as you start to think about it, if you change your mindset and expect infrastructure failures, you can then build your applications in a way to expect the infrastructure failure and kind of get over it. And there are ways of doing that. And we'll talk a little bit later on design principles, on how you can, expect an infrastructure failure and, again, react to it. But those are the two differences there. You have diverse technical expertise versus expertise that's focused on applications. We talked about this a little bit earlier. Diverse technical expertise means that there are different silos within your environment. You have a networking team, a storage team, a services team, servers team, a facilities team, etc. So you need technical expertise, and you have application teams. You have all of these teams with diverse technical expertise. With AWS, let's take away a large chunk of that, focus on your applications. That doesn't mean you don't need administrators anymore. You do. That doesn't mean you don't need networking folks anymore. You do. But those networking folks are now not just focused on networking. Why? Well, because they're not managing the hardware. They just need to be able to configure the networking the way you want it. So they should be able to also manage the servers, and they should be able to also manage the storage. So now that person that was a technical expert in just one silo can take on more because of the simplification. So focus on the applications mean we're going to abstract all the complexity of the physical hardware. You focus on the virtual and the logical pieces and focus on your applications, focus on what's going to make your business money. In a do-it-yourself, the applications are unaware of the infrastructure versus with AWS, the application could be aware of the infrastructure based on how you've developed it. And what do I mean by that? So let me kind of dig a little deeper into that. If you're installing an application on top of Microsoft server, right, a Windows server, the application doesn't know if you've clustered that server. The operating system knows that it's clustered, but the application doesn't. The application is expecting that infrastructure to be up and running. If the infrastructure fails, the application fails automatically. So the application is unaware. It can't see it. It can't make any calls to the infrastructure. It can't request more capacity, nothing. All the application can do is perform poorly, and as a result, you would have to figure out, why is this application performing poorly? Does it need more RAM? Does it need more CPU? What's causing that slowness? And then you address it that way. With AWS and with cloud in general, applications can be aware of infrastructure depending on how they've been developed, which means if you're developing your application properly against the cloud, the application can be aware of the infrastructure and can make requests, can make calls to the infrastructure to provision additional resources when it needs them. So if the application requires more web servers because the load went up, the application can make a request to provision more web servers. If it requires more database servers or services, it can make that request as well. So the application is in tune, it's connected to the infrastructure and can manipulate the infrastructure to a large degree. Those are differences. Now again, the application would have to be developed that way. You're not going to take a traditional client-server application and make it aware of the infrastructure. What you can do is take a traditional client-server application and put some automation around it, which means if the application hits 80% CPU utilization, I want you to automatically provision 3 more web servers. You can do stuff like that. But true service-oriented architectures, SOAs, are built with the application controlling the infrastructure instead of the application unaware of the infrastructure and just expecting it to be reliable. With do-it-yourself, you have high upfront costs. Again, we go back to that same example. You buy 100 servers, but your need is just 50 servers. And then when you cross that boundary of 100 servers, you buy another 100 servers when your need is just 50 servers additional. You have to buy all the networking and storage and facilities that, again, correspond to this server purchase that you just made. So all of these are high upfront costs. With AWS, it's usage-based costs, right? If you need 50 servers, you use 50 servers, you pay for 50 servers. You don't need 50 servers, you don't pay for them. So it's pay per use as opposed to those high upfront costs. You have design, build, operate, and support. That's for the traditional do-it-yourself. You have to do all of those. With AWS, they've taken away a lot of that complexity, right? So you need limited knowledge of the AWS environment. But you don't really need to know how they've configured their storage. You need to know how you can leverage the storage. You need to know how many tiers of storage they have so that if the application requires high-speed storage, you know where to put it. But you don't really need to know the Python code that they're using, for example, for storage. You don't need to know what type of storage they have. Is it EMC or Hitachi or NetApp or whatever? You don't need to know all that stuff. You don't need to know how they're replicating it. You just need to know that the data is being replicated. Now, you also have the concept of shared support. Support is never going to be a 100% Amazon or 100% you in a cloud. It's going to be shared because there's a portion that's Amazon is responsible for, and we'll talk about that later, and there's a portion that you're responsible for. So there's that shared support model that's going on there as well.